Hello everyone. Today we are going to explore topological sort, a concept used to arrange elements in a specific order based on their dependencies. Let's begin with the basic definition. Topological sort is a way of arranging vertices in a directed acyclic graph, also called a DAG. In this arrangement, for every directed edge from U to V, vertex U comes before vertex V. It is important to remember that topological sorting works only for graphs that do not contain cycles. To understand this better, let's see a real-life example. Before studying data structures, we must learn programming basics. Before studying algorithms, we must complete data structures. So the correct order is programming basics, data structures, algorithms. This kind of correct ordering based on dependencies is called topological sorting. Next, types of approaches. There are two main approaches to perform topological sorting. First is the in-degree method, also called Kahn's algorithm. It uses a queue and works using breadth first search. In-degree method is a way to perform topological sort by selecting vertices in degree equal to 0. That means no incoming edges. We remove those vertices one by one and reduce the in degree of their neighbors. Second is the depth first search method. It uses a stack and works by visiting nodes deeply before moving forward. After finishing DFS, we pop the stack to get the correct topological order. Both methods works only for directed acyclic graphs. Now let's see an example. We have vertices 0, 1, 2 and 3. The edges are 0 to 1, 0 to 2, 1 to 3 and 2 to 3. This is a directed acyclic graph. We will now find the topological order step by step. First, we find the in degree of each vertex. Vertex 0 has in degree 0. So we start with it. Next, we remove vertex 0 and update the in degree of its neighbors. Now, vertex 1 and 2 become 0. So we add them to the queue. Then we remove 1, update values and move to 2. After that, vertex V becomes 0 and is processed. Finally, the topological order is 0, 1, 2 and 3. Now let's look at the algorithm briefly. First, calculate in degree for all vertices. Then add vertices with in degree 0 to a queue. Remove elements from the queue one by one and reduce the in degree of their neighbors. If any neighbor becomes 0, add it to the queue. If all vertices are processed, we get the topological order. Otherwise, the graph has a cycle. Now, let's understand the Java program for topological sort using breadth first search. First, we import the required packages and create a class. Inside the main function, we use a scanner to take input from the user. We first read the number of vertices and the number of edges. Next, we create an adjacency list to store the graph. This helps us represent the directed edges between vertices. Then we take the edges as input. For each edge from U to V, we add V to the adjacency list of U. After building the graph, we create an array called integrity. This array stores how many incoming edges each vertex has. We calculate the integrity by going through all adjacency lists and increasing the integrity of connected vertices. Next, we create a queue. We add all vertices with integrity 0 into the queue. These are the starting points because they have no dependencies. Now we begin the main process. While the queue is not empty, we remove a vertex from the queue and print it. Then for all its neighbors vertices, we reduce their integrity by 1. If any vertex becomes 0, we add it to the queue. This process continues until all vertices are processed. The printed order is the topological chart. Now, when we run this program, we give the input as vertices 0, 1, 2, and 3, and the edges 0 to 1, 0 to 2, 1 to 3, and 2 to 3. Based on this input, the program generates the topological order as 0, 1, 2, and 3. This output shows that each vertex appears only after its dependency are completed. Complexity analysis. The time complexity of topological sort is order of V plus V. The space complexity of topological sort is order of V plus V. Here, V is number of vertices, V is number of edges. The applications of topological sort: task scheduling, course prerequisites, software build system, dependency resolution, detect deadlocks in operating system. Next, advantages. It is fast and efficient, helps in ordering tasks correctly, useful in real life problems. Then, disadvantages. Works only for directed acyclic graphs. Cannot handle cycles. Multiple valid orders are possible. Finally, topological sorting is an important concept used to order tasks based on dependencies. It is widely used in computer science applications like scheduling and dependency resolution. Thank you for listening.